April 11, 1941, Wright Field, Dayton, Ohio. The conference room at Wright Field held 14 men on the morning of April 11, 1941, and the air carried the smell of coffee gone cold, and cigarette smoke layered thick beneath fluorescent lights that hummed with a frequency that seemed to match the tension in Major General Henry H. Arnold's jaw as he stood before the wall map showing the Atlantic Ocean stretching 3,000 miles between New York and Liverpool, a distance that represented not merely geography, but the fundamental problem facing American strategic planning in the spring of 1941, when Britain stood alone and the possibility of its fall consumed every contingency discussion in the War Department. Colonel Carl Green from the Air Corps Material Division spread the preliminary specifications across the oak table, documents stamped confidential in red ink, outlining requirements for a bomber with 10,000-mile range, cruising at 300 miles per hour at altitudes above 40,000 feet, capable of carrying 10,000 pounds of ordnance from bases in the continental United States to targets in Berlin or Frankfurt, and returning without landing. A requirement born not from ambition, but from apocalyptic calculation. The recognition that if the Royal Navy succumbed and German forces occupied Britain, if the Azores and Iceland fell to Axis control, American air power would possess no forward bases from which to strike Europe, leaving only the possibility of intercontinental bombardment launched from American soil across an ocean that had protected the nation since its founding, but now represented strategic isolation. Lieutenant Colonel Grandison Gardner from the Air Corps Board reviewed meteorological data showing prevailing westerlies that would assist eastbound crossings but penalize return flights, calculated fuel consumption rates for various power plant configurations, noted that no existing engine technology could sustain such demands without revolutionary advances in propulsion and aerodynamics, while Captain Robert Woods from Consolidated Aircraft sat quietly absorbing the magnitude of the request, understanding that what the Army Air Corps proposed exceeded every principle of aircraft design practiced to that date, required wingspan approaching 200 feet, fuselage dimensions comparable to a railroad car, and weights that would exceed anything currently rolling down American assembly lines by factors of 3 or 4. The meeting extended through morning into afternoon as engineers debated pusher versus tractor propeller configurations, argued the merits of radical wing loadings, calculated structural stresses on airframes subjected to transatlantic turbulence and combat damage, while outside the windows, B-17 flying fortresses practiced formation flying over the Ohio countryside, their 4 engines droning steadily, aircraft that represented the cutting edge of American heavy bombardment, but possessed range barely sufficient to reach Iceland from Newfoundland, inadequate by 3,000 miles for the mission now under discussion. By 1600 hours, the requirements had crystallized into formal specification XC-218, calling for 5,000-mile combat radius, a figure derived from the distance between Wright Field and Berlin, with margins for adverse winds and combat maneuvering, pressurized crew compartments to sustain human life at stratospheric altitudes, defensive armament sufficient to ward off fighter interception, and bomb bay capacity adequate for contemporary ordnance while maintaining structural integrity during transcontinental flight at weights approaching 250,000 pounds. Green emphasized that 4 manufacturers would receive the specification: Boeing, Consolidated, Douglas, and Northrop, but made clear the urgency stemmed from intelligence assessments suggesting German invasion of Britain could occur within months. Operation Sea Lion delayed but not abandoned. Wehrmacht divisions massing across the Channel. Luftwaffe achieving temporary air superiority if RAF Fighter Command exhausted itself in protracted defense. Scenarios that kept Roosevelt and his military advisors wakeful during Washington nights, when radio broadcasts from London carried sounds of anti-aircraft fire and bomb detonations echoing across the Atlantic. Woods departed Wright Field that evening carrying documents that would transform Consolidated Aircraft from a company producing patrol bombers and trainers into the developer of aviation's most ambitious project. Drove through darkening Ohio landscape toward the train station, where he would begin the journey back to San Diego. Understood that the aircraft described in specification XC-218 represented not merely technical challenge, but existential insurance policy. A weapon designed for a world where America stood alone, where the Atlantic provided no protection, where strategic bombardment of industrial targets in the Ruhr Valley and Silesia must originate from Kansas or Nebraska, launched across an ocean empty of friendly bases, executed by crews who would spend 24 hours or more in unpressurized cold at altitudes where oxygen deprivation killed within minutes and temperatures fell to 60 degrees below zero. The specification existed in 4 copies locked in War Department safes that night, while across the Atlantic, RAF bombers struck German positions in occupied France and Royal Navy destroyers hunted U-boats in the western approaches, Britain still holding but the margin narrowing. American planners already preparing for contingencies that would require strategic air power to span continents and oceans on missions that exceeded human endurance and technological possibility, but could not be avoided if history took its darkest turn and left America to fight alone across distances that seemed designed by Providence to protect, but now represented the very problem that demanded solutions no aircraft had ever attempted.
October 28, 1943, Consolidated Vultee Aircraft Plant, Fort Worth, Texas. The mock-up of Model 36 occupied Bay 7 of the Fort Worth facility on October 28, 1943, a full-scale wooden representation measuring 163 feet in length with wingspan of 230 feet, dimensions that dwarfed the B-24 Liberators being assembled in adjacent bays, where riveters worked 3 shifts producing bombers for European and Pacific theaters, while in the sealed section behind guarded doors, engineers confronted the reality that the war's trajectory had fundamentally altered the strategic calculus that birthed specification XC-218 2 years earlier. Britain had not fallen. North Africa belonged to Allied forces. Sicily and southern Italy were under Anglo-American control, and 8th Air Force operated from English bases launching 1,000-bomber raids against German industrial targets. Yet the B-36 program continued, not from obsolescence avoided, but from recognition that strategic requirements evolved and intercontinental range possessed value beyond the original Doomsday scenario. Potential applications in Pacific operations against Japanese home islands if island hopping campaigns stalled. Capability to strike Soviet industrial centers if post-war cooperation deteriorated into confrontation. And fundamental principle that air power untethered from forward basing infrastructure represented permanent advantage in future conflicts whose geography remained unknowable. Major Harold Carr from Air Materiel Command walked through the mock-up's interior, ducking through pressure bulkheads, examining crew station layouts, where pilots would sit side by side in a flight deck positioned 60 feet behind the aircraft's nose. Navigator and bombardier stations located in the extreme forward fuselage, accessed through a crawl tunnel too narrow for men wearing parachutes. Engineer and radio operator positions amidships, surrounded by fuel tanks holding 36,000 gallons of gasoline, and 6 gunner stations distributed throughout the aircraft's length, each position representing compromise between combat effectiveness and the weight constraints that governed every design decision. The propulsion system had evolved through 18 months of calculation and wind tunnel testing, settling on 6 Pratt & Whitney R43060 Wasp Major engines, each producing 3,000 horsepower, mounted as pusher configuration on the wing's trailing edge, a radical departure from conventional tractor arrangements, but necessary to position propellers behind wing structure, reducing interference drag and allowing larger diameter propellers operating at lower rotational speeds for improved efficiency at high altitude, where thin air challenged traditional power plant performance.
Consolidated's chief engineer, Mac Ladden, explained to visiting War Department officials that the aircraft would cruise at altitudes above 40,000 feet, where temperatures reached minus 60 degrees Fahrenheit, requiring cabin pressurization systems that maintained sea-level atmospheric pressure for crew comfort and combat effectiveness during missions projected to last 30 hours or more, duration that exceeded human endurance limits unless physiological considerations received equal priority with aerodynamic and structural concerns. Wind tunnel testing at the National Advisory Committee for Aeronautics facility in Langley had revealed unexpected challenges with the wing design, a configuration utilizing laminar flow airfoil sections intended to reduce drag at high speeds, but sensitive to surface imperfections and manufacturing tolerances difficult to maintain in production environment, leading to debates whether theoretical performance advantages justified practical complications. Arguments that continued through 1943 as engineering teams refined specifications while production facilities expanded and material allocations competed with established programs producing aircraft already killing Germans and Japanese across two hemispheres. The mock-up review revealed crew access problems that would require redesign. Emergency egress from forward compartment involved crawling aft through tunnel barely large enough for a man without equipment, impossible during combat damage scenarios. And landing gear retraction mechanism occupied space needed for bomb bay capacity, forcing engineers to reconsider wheel well placement and structural reinforcement requirements. By late afternoon, the visiting officers had documented 47 design modifications required before prototype construction could commence, changes that would delay first flight estimates into 1945, a timeline that troubled War Department planners who recognized the war might conclude before the B-36 proved its operational worth. Yet cancellation seemed premature given the aircraft's potential value in post-war strategic posture, and the reality that development programs required years from specification to operational deployment, time that could not be compressed without abandoning engineering rigor and accepting catastrophic failure rates. Outside Bay 7, the Texas sun heated tarmac to temperatures approaching 100 degrees, while inside the climate-controlled facility, engineers measured clearances and calculated stress loads, work proceeding with methodical precision despite uncertainty about whether the aircraft would ever drop bombs on enemy territory or serve instead as technology demonstrator, a platform proving that intercontinental bombardment was achievable, that American engineering could solve problems of range and altitude that seemed insurmountable in 1941, that strategic air power need not depend on forward bases vulnerable to enemy action or diplomatic reversal. The mock-up stood in Bay 7 through November and December, while the actual prototype's components began fabrication in scattered facilities, wing sections manufactured in San Diego, fuselage sections in Fort Worth, a distributed production strategy born from factory space limitations and desire to protect the program from single-point failure if German saboteurs or Japanese agents targeted American aircraft industry. Paranoia that seemed excessive in autumn 1943, but reflected security consciousness pervading military programs whose strategic importance demanded protection against every conceivable threat. The war continued its grinding progression through those months, 8th Air Force suffering terrible losses over Schweinfurt and Regensburg, Pacific forces advancing through the Solomon Islands, the Red Army pushing westward from Stalingrad's ruins. Campaigns that absorbed national attention and military resources, while in Texas, engineers worked on an airplane designed for a war that had not occurred and might never occur. Yet they worked with conviction that strategic preparedness transcended immediate tactical requirements, that weapons built for contingencies provided options when history demanded flexibility, that the B-36 represented not obsolete planning, but investment in capabilities whose value would emerge in conflicts not yet imagined by populations focused on present enemies rather than future uncertainties. September 8, 1945. Consolidated Vultee Airfield, Fort Worth, Texas. The XB-36 prototype sat on the Fort Worth ramp on September 8, 1945, registration number 4213570, painted in regulation markings across its aluminum skin. 6 Wasp major engines silent in the Texas heat, 25 days after Japan's surrender, and 3 weeks after the war's formal conclusion aboard USS Missouri in Tokyo Bay. The aircraft completed too late to influence the conflict that spawned its creation, yet standing as testament to engineering persistence across 4 years of development that paralleled America's transformation from neutral observer to global military power. Chief Test Pilot Beryl Erickson conducted pre-flight inspection in morning light that cast shadows emphasizing the aircraft's massive proportions, wingspan exceeding a football field's length, vertical stabilizer rising to 46 feet above tarmac, landing gear struts thick as tree trunks, supporting weight approaching 162,000 pounds empty, a figure that would nearly double when fuel tanks filled and ordnance loaded. Numbers that represented extreme extension of aviation engineering principles governing structural strength, aerodynamic efficiency, and propulsive power. The cockpit instruments covered panels extending across both pilot stations, with gauges monitoring fuel flow, oil pressure, cylinder head temperatures, manifold pressure, propeller pitch, electrical systems, hydraulic pressure, oxygen supply, cabin pressure, and dozens of parameters essential for safe operation of systems too complex for single-pilot management, requiring flight engineer constant attention to power plant performance and system status, while pilots focused on aircraft control during phases of flight where margins between success and catastrophe measured in degrees of control input or seconds of reaction time. Ground crews had spent the previous week completing final systems checks, bleeding hydraulic lines, calibrating instruments, balancing flight control surfaces, procedures conducted with thoroughness that reflected understanding that first flights killed test pilots with depressing regularity when unknown characteristics manifested at altitude or speed, when theoretical calculations proved optimistic or structural components failed under loads not adequately anticipated during design phase, when any of 10,000 parts manufactured by different suppliers, assembled by different workers, using specifications interpreted with varying precision, revealed incompatibilities that resulted in mechanical failure or aerodynamic instability. Erickson started engines at 0930 hours, each Wasp major coughing to life with propeller rotation accelerating through mechanical grinding into smooth power delivery. 28 cylinders per engine combining to produce 18,000 horsepower total when all 6 operated normally. Fuel consumption measured in gallons per minute rather than per hour. Operating costs that would burden peacetime budgets but seemed irrelevant during development program funded by wartime appropriations when national survival appeared to justify any expenditure that promised strategic advantage. Taxi tests consumed the morning as Erickson evaluated steering response, brake effectiveness, visibility from cockpit positioned far above ground level, procedures necessary before committing aircraft to flight when unknown handling characteristics could prove fatal if discovered too late for corrective action, when pilot workload might exceed capacity for simultaneous management of flight control, power management, systems monitoring, and decision-making required during emergencies at altitudes where oxygen deprivation impaired judgment and cold numbed extremities, and fatigue accumulated during missions lasting hours beyond normal human operational capacity. The decision to abort the first flight attempt came at 1100 hours when number 5 engine showed oil pressure fluctuations suggesting potential bearing failure. Mechanical problem that would require engine removal and inspection. Delay that frustrated engineers who had worked through summer heat toward this moment, but who recognized that test flying demanded absolute mechanical reliability, because experimental aircraft offered no margin for equipment malfunction when flight characteristics remained unknown, and emergency procedures were untested theory rather than practiced routine. The XB-36 returned to its hangar that afternoon while mechanics removed the suspect engine, work proceeding under lights through evening and night as technicians disassembled the Wasp Major, inspected bearing surfaces, measured clearances, searching for the defect that had manifested as pressure fluctuation, finding, eventually, a contamination in the oil gallery that had restricted flow. Problem solved through cleaning and reassembly, but costing days while autumn approached and weather patterns shifted toward conditions less favorable for test flying. The delay seemed almost symbolic, the aircraft built for a war that had ended, arriving too late to validate its design assumptions. Created to bomb Germany from American bases if Britain fell, but now sitting in Texas while Germany lay occupied and divided. Conceived as insurance against worst-case scenarios that had been avoided through combination of British resilience, Soviet sacrifice, American production, and technological advances including atomic weapons that rendered long-range conventional bombardment potentially obsolete before the B-36 ever left the ground. Yet the program continued because strategic planning operated on timescales exceeding immediate conflicts, because military capabilities took decades to develop and could not be improvised during crises, because the B-36 represented not merely one aircraft, but proof that intercontinental operations were achievable, that American air power could reach any point on Earth from bases within American territory, that future conflicts might demand capabilities that seemed excessive or irrelevant in September 1945, but would prove essential in scenarios not yet imagined by populations celebrating peace and demanding demobilization. The prototype would fly eventually on August 8, 1946, nearly a year after war's end. A maiden flight that would reveal handling characteristics generally satisfactory, though control forces were heavy and range performance fell short of specifications, limitations that would require years of modification and engine upgrades before the B-36 entered operational service with Strategic Air Command in 1948. Where it would serve as primary nuclear deterrent through the early Cold War, carrying atomic weapons on airborne alert missions that patrolled American airspace ready to strike Soviet targets if war came. A mission that validated the original concept of intercontinental bombardment, though the enemy and weapons had changed from those envisioned in Wright Field during spring 1941 when the project began. The aircraft stood in its hangar on that September evening in 1945, maintenance crews working under harsh lights, Fort Worth quiet except for mechanical sounds and distant traffic, while across America veterans returned home and factories converted to peacetime production, and populations tried to comprehend the war's cost and meaning, unaware that the enormous airplane being prepared for its delayed first flight represented continuity between the war just ended and conflicts that would consume the next half-century, that the B-36's intercontinental range and atomic payload would become foundation of nuclear deterrence strategy, that the emergency contingency weapon designed for a catastrophe that never occurred would transform into the primary instrument of strategic air power during decades when peace depended on capability to deliver devastating retaliation against any aggressor, making the B-36 not a weapon too late for its war, but rather too early for the conflict it would actually serve. Arriving at history's intersection between conventional warfare's conclusion and nuclear age's beginning, embodying transition from wars fought for territory and ideology to stalemates maintained through mutual assured destruction, from conflicts decided by industrial production and soldiers' courage to standoffs sustained by technological capability and willingness to accept apocalyptic consequences. The XB-36, sitting silent in Texas, represented all of this, though no one working that evening could fully comprehend how thoroughly the world had changed, or how the airplane they were preparing to fly would help define the strategic reality that would govern international relations until the Cold War's end 4 decades hence.